Hello students, here are some tips and clues on working out the questions in problem set 3. Before we get there, we have to know a couple of terms. Number 1, torque. Torque is the rotational effect of force. The rotational effect of a force. Think about turning a wrench or opening a door. Now, what's given in the diagram is you're trying to apply a force and you're trying to open a door. So the force is being applied here. This is the line of action of the force. And here is where the hinges are. So that is the axis. It's called the axis of rotation. So you have where you're applying the force, and you also have the axis. And this is the distance. R is the distance between the force and the axis. It's actually the perpendicular distance. That's the symbol for perpendicular. Now to calculate the torque, we have to multiply the force in newtons with the distance in meters. So torque is simply the product of force and distance between the force and the axis. That's number 1. Number 2, friction exists everywhere. It resists motion. That's why your shoes don't slip on the floor, except when there is a little water on the floor, and then your shoes begin to slip, showing that friction depends on what type of materials are in contact. And there are 2 types of friction. One is static friction, the other is kinetic friction. Static friction is what holds objects in place. So the furniture in a room stays in place because of static friction. Otherwise, they would have been running around, and that would have been horrible. Kinetic friction slows objects when they are moving. Like if you take a ball and roll it in the hallway, the ball is going to come to a stop, and that's because of kinetic friction. So these are the 2 types of friction. Number 3, you have to know how to break a force into its components. Now this is called resolution of forces, and unfortunately a little bit of trigonometry comes in. But I'll keep it simple. And there's a good example given here, like if you aim a slingshot diagonally, you're actually pulling in 2 directions. You're pulling vertically and horizontally. The slingshot is moving both horizontally and vertically because you're moving diagonally. Okay? So that kind of explains that any vector, as you can see here, vector A, can be broken up into its x component, which is a sub x, and its y component, which is a sub y. And that's where sine and cosine is going to come in. I'll introduce that later. Okay. Finally, in this chapter, we have to learn about centripetal force. Centri means center and petal means towards. So centripetal force is a force that acts towards the center. That means this force acts on any object that moves in a circular path, like a planet orbiting the sun, or if you have a string with a stone tied at one end and you hold the other end in your hand and then rotate it, there is a centripetal force that's keeping the stone moving around in a circular path. And the formula for centripetal force will come in later. It's a mass times square of the velocity by radius. Don't worry about it right now, but just know that there is centripetal force and there's also centripetal acceleration. Okay? Centripetal acceleration multiplied by the mass is going to give you centripetal force. Let me say that again. Mass multiplied by acceleration gives force, right? F is equal to m times a. Let me see if I can write with this. Okay. Force is always mass times acceleration. So ma. So if it's a centripetal acceleration, then you're going to get the centripetal force. That's it. So those are the topics that you need to know to understand this chapter. All right, let's get to the problems. Here is the first one. It shows two people sitting at opposite ends of a teeter-totter. The lady has a mass 60 kilogram and the man 80 kilograms. And you can see their positions. 1.25 meter here. Okay, 1.25 meter here, and there's 1.5 meter. This is the axis of rotation, because that's where the teeter-totter is going to rotate about. And there's also an object, let's call it the mystery object, because we do not know its mass. So that is A. So you have three objects. That means there are three forces acting vertically down. Number one, the weight of the lady, which I have represented as F sub W. Then you have the force or the weight of the object, F sub A. And finally you have the weight of the man, which is force sub M. Now there are these three forces acting down, but to maintain equilibrium, there is a fourth force at the support acting vertically up. So there are four forces. When you draw all these forces acting on an object, that is called the free body diagram. So question number 1 says, draw a free body diagram for the system. I have already done it for you. Free body diagram means showing all the forces acting on the system. And then I've also shown you how to calculate the weight of each person. How do you calculate the weight? Weight is mass multiplied by the acceleration due to gravity. Okay, so the mass of the lady is 60 kilogram. You multiply that with 9.8, which we know is the gravitational acceleration. You will get the force or the weight of the woman, okay, or the lady. Similarly, you multiply the mass of the man, which is 80 kilogram, with 9.8, you get the weight of the man. And do the same for the third one, but we do not know its mass, so we will just leave it as m sub a times 9.8. So now I've shown you the forces, and I've also calculated the three forces. In fact, you can get the fourth force, which is F sub S, because you know what? That has to be equal to the sum of the other three. Alright? So F sub S must be equal to the sum of these three. Now let's go to the B part. The B part says calculate the counterclockwise torque. You must know the direction in which a clock rotates. It's like this. See, it goes like that. That's the 12, the 3, the 6, the 9, and back to the 12. So that's clockwise. That's why this is labeled CW. Clockwise. This is counterclockwise because it's going in the opposite direction. So B says calculate the counterclockwise torque. There are two counterclockwise torques. One is because of the weight of the lady. So how do you calculate that? You go multiply the weight with 1.5. Why 1.5? Because that's the distance. Remember, torque is force multiplied by distance. Plus, you also have F sub A times 0.5. 0.5. So that's the total counterclockwise torque. Now this symbol, sigma, that's what it's called, stands for total or net. And this symbol stands for torque. In Greek it's tau, T-A-U, tau. I know, you got to learn Greek as well. So that's the total counterclockwise torque. Then C says calculate the clockwise torque. There's only one force on this side, and that's creating the clockwise torque. So it should be F sub M multiplied by 1.25. But you know what? Clockwise torques are taken as negative. So that's why I have included a negative here. Now you got to substitute the numbers and calculate it. Please don't leave it like this. You have to complete the calculation. I'm not doing everything for you. You got something to do. Alright, now the D part. What is the total torque and the total force? The answer is right there. If a system is in equilibrium, like this is, then both the torque and the net force must be 0. So that's why I have put that there. Look at that. Net torque is 0 and net force is 0. And finally, part E, very important question. What is the mass of the mystery object? What you can do is, you can either set the total torque to be 0, or you can set the total force to be 0. And I think it's easier to set the total force to be 0. And that way you should be able to calculate the unknown force. See that? Because if you add all the forces acting down, which is the 3 forces acting down, that must equal the force acting up. So let's see if you can do it that way. Or use this method. Substitute, because you already got the total counterclockwise torque here. Put that here. You got the clockwise, include the negative, so this will become negative something is equal to 0, and then you should be able to solve for M sub A. So that's question number 1. That brings us to question number 2. Please take a few seconds to read the question and understand. So 2 muscles in the back of the leg pull upward on the Achilles tendon as shown in the figure. Now these muscles are called the M and the L heads. Okay, so we just need to label them. So you see the F sub M, and that's applying 200 newtons. It's given here. So you have the 200 newtons here. And the other one is also applying 200 newtons, but it's acting at an angle of 20 degrees with this dotted line. Okay, now get ready for some math. Not so tough if you pay attention. I've redrawn the diagram, but let me show you. If this angle is 20 degrees, this angle is going to be 70 degrees because the total is 90, all right? So if this is 20, this is 70, because 70 plus 20 is 90. So that's why I have actually labeled that angle as 70. And then this is our 200. The red vector is 200. and we have to use trig to break it into its components. I'm not going to go into details here, but from the definition of sine and cosine, the x component, this is the x, will always be whatever the number here, the 200 here, 200 multiplied by cosine of the angle. So enter that into your calculator. Now make sure that your calculator is in the degree mode. Otherwise, you won't get the same numbers. So go ahead and enter 200 times cosine of 70. You're going to get 68.4 newtons. Now the y component, because that's on the y-axis, would be 200 sine 70. So that would be 188 newtons. That's all we need to do. But once we do that to this F sub m, we could do the same to F sub L on the left side. When you do that, you can see these red arrows that I've shown to help you understand that the x components are going to be equal and opposite, right? Because this is going to have an x and a y, just like this has an x and a y. So what's happening is the x components being equal and opposite cancel out. So there's no net x. But notice that the y components are both up. Therefore, they add up. So the total y component would be 188 plus 188, okay? So that's why you see I've explained the answer to part A. The x components cancel out, but the y components do not. And what you have to do is you have to add the 188 twice, and whatever number you get here would be the net force on the y-axis. Okay, I think I made a mistake here. This should be y, so it should be FLY. That's plus FMY. So this should be L and Y, because we are adding the y components, okay? So please correct that. Then the C part says find the magnitude of the total force. Well, the total force is simply, when it says magnitude, you're looking for the absolute value, okay? The total force is simply the sum of the y components. So 188 plus 188, yeah, because the x cancelled out. So that's a repeat question. Find the direction of the total force. Well, upward, it's upward. That means it's along the positive y direction. Yeah, I just told you. Both the 188s act up, and that's the positive y-axis. So that's question number 2. Alright, question 3. Again, read the question. You can pause the video, read the question. But I'll explain it to you. Here you are talking about the human head, and the head has a weight, actually a mass of 5 kilogram, as you can see, 5 kilogram there. And CG stands for center of gravity. That's the point through which the weight acts down. So you can see the weight acting down, the weight of the head. And remember, the weight of the head is not 5 kilogram. That's the mass. To get the weight, you'd have to multiply it with 9.8. So the weight of the head would be 49 newtons. So that's acting right here. And that's going to create the clockwise torque, because it's trying to rotate it that way. Here is the axis. You see that little black triangle? That's the axis where the head is rotating. So to find the torque due to the weight, you got to multiply 49 newtons with this distance. But remember, this is in centimeters. You got to change it into meter and multiply. So 49 multiplied by this in meters will give you the clockwise torque. On the other side, you have the muscles exerting a force F sub m and creating the counterclockwise torque. See that? So that's trying to keep the head up. Otherwise, it would just fall. Okay, like when you feel sleepy. So to calculate the counterclockwise torque, once again, you got to know the force that the muscles are exerting multiplied with this distance, but 5 centimeter. Again, you have to change it into meter. And if the head is kept straight, like when a person is not sleepy, then you know the clockwise torque must be equal to the counterclockwise. I've explained everything in this question. Okay, part A, find the weight of the head. I already told you. Find the torque due to the weight of the head. I did tell you. I've even changed the centimeter into meter. I'm being kinder by the day. Okay, so to find the torque, you got to multiply the weight, which we have here, with the distance, right? Which is here, okay. Then again, same way, counterclockwise would be the force due to the splenius muscles with the distance. Now, we know the distance, but we do not know this. So we can find it by setting these two equal. Because we know the clockwise torque must be equal to the counterclockwise torque. So that's what I've done here. So you know this is 49, right? And just by doing the math, you should be able to calculate this force, this one. You would get it in newtons. Then D is simply a repeat. Once you get the force, you just multiply it with 0.5 and you would get the torque due to the splenius muscles. It's just a repeat. And which makes a counterclockwise torque and which is clockwise, I've already explained it. I think you should be able to figure that out by looking at the direction of rotation, right? All right, number 4. Excuse me. Now, number 4 is about friction. And what's actually happening here is the car or the cars are trying to take a curve. They're going around a curve, which is part of a circle. So centripetal acceleration comes into play. Now, there is the coefficient of kinetic friction and the coefficient of static friction. That's given both for when it's dry and when it is wet. And you can see that when it is wet, there is a decrease in both the coefficients, you see. But I want to tell you that although the car is moving, the tires are not slipping on the road. So the tires are actually gripping. Did you hear the two words? The tires are gripping, not slipping. Therefore, we will only consider static friction. Again, I know the car is moving, I do. But we're going to consider static friction because the tires are not slipping. So kinetic friction here is given to throw you off. Yeah, you don't need the two kinetic frictions. Okay. So first, when the road is dry, that means we're going to use this value. Okay. What you have to do, what's the normal force? Now look at this free body diagram. There are 3 forces that act. Number 1, it's the weight of the car, F sub G. Number 2 is the reaction of the weight. Because you know the car is pushing down on the road. Hope you're listening. But the road is also pushing back up on the car. Because if it was not, then the car would sink down. As long as the car is not sinking down, you know that the road is pushing back on the car. That's called the normal force. Because it's actually perpendicular to the road, okay? As you can see, I've drawn it perpendicular to the road. So that's the road, okay? And then the third force is the centripetal force. So this is going to be the center of the circle, kind of, because that's the circle, right? So that's the center. So you have that third force acting towards the center, which is what is actually keeping the car on that track. Otherwise, it would have just gone straight and off the road. Okay. So there are three forces acting. And just from what I explained, you should know that the normal force is always equal to the weight, because you want them to be balanced. You do not want the car to go down into the road, neither do you want the car to jump up while taking the curve. That would be horrible. So I've answered that question. Normal force is always equal to the weight, which is mg. So calculate that. The mass of the car is given, is right here, so you should be able to calculate its weight. Now, centripetal force. In this case, the centripetal force is provided by friction. And the formula for friction is right here. So F sub F means friction. So I'm saying centripetal force is actually friction, which is always mu s times Fn. Now, mu s is 1.0 and Fn we got from here, plug it there, you should be able to get the centripetal force. Part C. Calculate the maximum speed at which a car can turn around a radius of 30 meters when the road is dry. So now what we got to do is, to find the maximum speed, you have to use the formula for centripetal force, which is here. Mass times velocity square by radius. That is the formula for centripetal force. Remember that from part B, we already got the number. Once you multiply it with this, you got an answer. So you put that number here. See, that's what I'm showing. Look at that. Put that number here and solve for velocity. Because you know the mass and you know the radius. Yes, the radius is given. Where is it? Oh, it said somewhere. Oh, it's here. The radius is 30 meters. The mass is 1,000 kilogram. Plug in those two numbers. And here, whatever you get the answer for part B, put that and solve. Now you got to do the same thing when the road is wet. There's only one difference. Oh my goodness, I just made a mistake here. Okay, I apologize. It should be static friction. Once again, it's static friction, never kinetic. When the road is wet, but the difference is you're going to use 0.7 when the road is wet. Okay, 0.7. I might as well change this before somebody sees it. Okay, where's that? Okay, that's mu s. Oh, all right, much better. So whatever we did when the road is dry, just do it when the road is wet. The only difference is you are using 0.7 here. This is the same that you got, for Fn when you calculated it here. So that's the same. And then once again, to find the maximum speed, do all of these steps together. Just put that. Okay. So whatever answer you get for this, when you do it, put that equal to this whole thing, and then plug in the values of mass and radius and calculate. I mean, this is not quite as the same as being in a face-to-face class, but if you pay attention, you're able to work this out, I am sure. Okay, the last one is the easiest one. So we should be done shortly. Calculate the acceleration of a car tire. The diameter is given while the car is traveling at that speed, 25 meters per second. Okay, so from the diameter you can find the radius, which is half of the diameter, and then the acceleration is the centripetal acceleration. This is the formula for centripetal acceleration, v squared by r. Plug in the values for this. Remember to square it. You should have the acceleration. And then this says, compare this with the acceleration experienced by a jet car tire of 1.0 meter diameter, but moving at 339 meter per second. So that's a jet tire, so it's moving faster. It's the same process, same formula, except you're using this velocity and half of this as the radius. You will get this number, correct? Once you get the two numbers, you have to find the ratio. So whatever you got here, divide by whatever you got here. Because the question says compare. Compare means you have to divide one by the other. And then you will get a very small number here. So that's the ratio. And that is the end of this problem set. I hope you did understand a little bit of this. I mean, this combined with the UJA quiz video lecture should make it very clear. Thank you. Wish you the best.